Hello, my name is Dominic. This is the first in the Collisions in FlatRedBall Deep Dive series of videos. These videos cover everything you need to know to work with collisions in FlatRedBall. We'll start with the basics, but we'll move deeper into more advanced topics in the later videos. I'm excited to show you everything we can do with collisions in FlatRedBall, so let's get started. What are collisions? Well, every game will consist of at least one screen. The screen will display all the elements of a game, including objects that can interact with each other in various ways according to your game design. For instance, a ball might bounce on the ground or a bullet might hit an enemy. These interactions are called collisions. The most common way to implement collisions in FlatRedBall is to use collision relationships in the FlatRedBall Editor. We'll start with this approach since it covers most cases and is fairly easy to implement. Collision relationships are typically added to your game screen. Each collision relationship defines how collisions should behave between two types of objects. If you've created your game with the new project wizard, and if you've selected either the platformer or top-down game types, then you already have collision relationships in your game. For this project, I'm using the platformer game, but the concepts are the same for a top-down game as well, so you should be able to follow along with either type of game. As I mentioned earlier, we can see our existing collision relationships by expanding the game screen's objects folder, then expanding the collision relationships. Notice that I have a collision relationship named Player versus Solid Collision. As the name suggests, this is a collision relationship between our player list and the solid collision defined by our map. Note that even though the name says player, singular, the collision relationship is actually between the player list and the solid collision. Most of the time, collision relationships are performed between either lists of entities and a tile-shaped collection, or between two entity lists. Even though our game only has a single player, it's best to always perform collisions between lists. This gives you the most flexibility in case you end up adding more players. For other entity types such as enemies or coins, it's quite common to have multiple instances, so I recommend getting in the habit of always making collision relationships involving lists. Collision relationships provide lots of options, but we'll start with the two most important. We can select the collision relationship, then select the collision tab. The first row indicates which types of objects are performing collision. Most of the time, you will set up a collision relationship and never change the two items in the relationship. The second most important option is the collision physics response. These options indicate how objects should react to colliding. Specifically, these options can result in changes to a colliding object's position and velocity. In some cases, such as the player object, collision may also set additional properties, such as whether the player is standing on the ground. If you created a platformer project, then the player versus solid collision automatically uses platformer collision. We can change this to no physics to see how this affects our game. Doing so should result in the player falling through the ground. Of course, this isn't really what we want in a platformer game, so I'll change it back to platformer collision. Collision relationships will almost always reference at least one entity list, and oftentimes two entity lists. For example, a typical collision relationship would be between player list and enemy list. By default, our game only has one entity type that is collidable, the player entity. We can create a second entity so that we can test out collision relationships. I'll create an entity type called ball, which should be a collidable entity, which uses a circle for its collision shape. To create the ball entity, right-click on the entities folder, select to add new entity, name the entity ball, check the circle collision. Notice that the entity is marked as iCollidable automatically. FlatRedBall assumes that you are trying to make a collidable entity if you create an entity with a shape. Notice that FlatRedBall also assumes that you want to have the ball list in your game screen. We'll leave that checked too. We'll need this list to create our collision relationships. Finally, click OK to create the entity. This is the most basic entity you could create. It doesn't even have a sprite, but that's okay for this video since we're going to be focusing purely on collision. Before we set up our collision, let's add some code to our game to dynamically create ball instances whenever the cursor is clicked. First, we'll make sure the mouse is visible so we can see where we're clicking. To do this, open the project in Visual Studio, select GameScreen.cs, and add the following code to custom initialize. Next, we can add an entity whenever we click on the screen. To do this, go to Custom Activity and add the following code. Notice that I am assigning a Y acceleration to the ball. This will give it gravity. If you're working in a top-down game, you may want to leave this line of code out, and instead just apply random velocity. We can run our game now and click the mouse. Every time we click, a new ball is created, and it moves in a random direction while falling to the ground. Great! Now we have ball instances, but you'll notice that each instance falls through the ground. Next, let's create a collision relationship between ball list and the solid collision. The easiest way to create a collision relationship is to drag and drop the entity list on the other object that it will collide with. In our case, we'll drag ball list onto solid collision. Note that we should create our collision relationships in game screen so that the collision applies to all levels. While it is possible to create level-specific collision relationships, this is almost never needed in games, and FlatRedBall will warn you if you try to do this. The newly created collision relationship is named Ball versus Solid Collision automatically. If we select this collision relationship, we can choose what kind of physics we want to have when a collision occurs. Let's make each ball instance bounce against the solid collision. Check the Bounce Collision option. Verify that the ball mass is set to 0. By setting the ball mass to 0, the ball will bounce off of the ground without modifying the ground collision. Since the ball has 0 mass, it is unable to push the rectangles in the ground. We almost always want to have a mass of 0 when colliding with the tile shape collection, so that we don't accidentally move the tile collision around. We can also set the elasticity, which controls the bounciness of the collision. An elasticity of 1 results in a perfect bounce. The ball will bounce off the solid collision at the same speed it had when the collision occurred. Let's drop this to 0.9 so that the ball loses a little bit of speed every collision, eventually settling down. Now that we've set this up, we can run our game again and test our collisions. Every time I click, I create a new ball instance. Let's try it out. Just like that, we've created a collision relationship. The best part is that we have our collision relationship defining a lot of our behavior, and it can be tweaked easily. For example, we can adjust the elasticity to make the ball bounce higher or lower. In fact, we can even have elasticity values greater than 1, which makes the ball bounce back with even more speed. Be careful though. With values greater than 1, they can result in objects moving so quickly that they tunnel through collision. So far, we've only worked with collision relationships between entity lists and tile shape collections. We can also create relationships between two entity lists. Let's create a collision relationship between our player list and ball list. I'll drag the player list onto the ball list, and this will create a player versus ball collision relationship. Once we have this collision relationship, we can set up the physics. I'll use bounce collision here as well so that the ball can bounce off the player. This time, however, I'll have each of the objects have a non-zero mass. I'll keep the player mass at 1, but set the ball mass to a value less than 1, like 0.2. This means that the ball only has 20% of the mass of the player. We can also give it an elasticity so that the ball bounces off the player. Let's try a value of 0.7. We can always tune it later. Now we can run our game, and the player should collide with the ball. We can even bump the ball by running more quickly or jumping. Notice that since the ball has a non-zero mass, the player is pushed back slightly when hitting the ball. We can adjust the elasticity and mass values to make the ball more bouncy or to make it feel more or less heavy. Physics and collision can be some of the most fun parts of game development, so I encourage you to try different things. Finally, we'll look at situations when entity types need to collide with each other. If we add a lot of ball instances to our game, we can see that they collide with the player and the solid collision, but they pass through each other. We can create collision relationships where the list collides with itself. The process here is a little bit different than before. To add this collision relationship, click on the ball list object in the game screen. Click on the Collisions tab. Notice that this tab lists all current and potential collision relationships. So far, we can see that the ball list collides with the solid collision. Locate the ball list and click the Add button. This creates a new collision relationship where each ball collides with every other ball. We can adjust the physics on this collision relationship just like we did before. Let's select Bounce Collision. In this case, each ball should have the same mass, so we'll leave the mass values both at 1. We'll set the elasticity to 0.6 to dampen the collision a little bit. Now, if we run the game, we can see that the balls self-collide. This can create some chaotic situations if we add enough ball instances. Also, if you spend enough time clicking, you can create enough balls that the game runs slowly. This happens because of the number of collisions. Each ball must collide with each other ball. When we have one ball and we add a second, we're only adding one additional collision. But if we already have 100 balls, adding just one more ball adds an extra 100 collision checks. By adding enough, the numbers can get large enough to overwhelm even the fastest computers. Don't worry. FlatRedBall offers solutions to this, which we'll cover in the next video. Thanks for watching. If you made it this far, then you should have an understanding of the basics of collision in FlatRedBall. Of course, there's lots more to cover, so stay tuned for our next video in the Collision Deep Dive series. My name is Dominic Daddy, and I'll see you next time.